I present an analytical over net energy with numerical investigation on fatigue smart crack. On fatigue, analytical over energy with numerical investigation on fatigue small crack and multi-axial criterion linked to the shear stress. Wow. The plane. Oh, nice. Summary. My summary is with an introduction where you have predicting the threshold stress and the rotating bending. So energy ingredient, I present energy under tensile and over energy under bending, over energy. So I present over energy in ellipse axis and the function of the threshold stress. I present analysis to predict stress, threshold stress. This stress is it's defined below the usual endurance limit, and this presentation numerical value are to define small crack associated to shear stress with curve with Kitawa curve and Bazant law. In part 2, I present the fatigue criteria and the validation of results, where you have multi-axial fatigue criterion according to over energy, under shearing stress. I put for validation of this criterion. For validation of this my criterion, I present the plane approach criteria and energy approach criteria. So I have some result for global analysis of multi-axial fatigue criteria and statistical indicator. So that I conclude. Part 1, you have the performance of the mechanic component with respect to the behavior in service can be degraded if a small crack appears at the surface. We use an asymptotic approach transformed over energy under rotating bending on biquadratic function assessment and predicting the threshold stress. So this stress is inferior to endurance limit. The small crack and shear stress reproduces well Kitagawa plot. The latter is bounded by the Bazant law. Part 2, you have the previous expression of multi-axial energy and the three-axiality function suggested by the layers are formulated the new criterion. Our multifacial fatigue criterion considered the shear stress in damage indicator A index 0. The latter requires beforehand the choice of the tensile through some experimental test. We note about the statistical indicator that our criterion is able to predict reasonable estimation. So here you have energy ingredient, energy under tension, energy over energy on area influencing small crack, omega TE here, and you have rotating bending energy here. For fatigue initiation crack, we have W with Y étoile, R étoile, over energy expressed in circular in the circular and ellipse axis is defined in this expression. So here we have over energy in ellipse section and function of threshold stress. You have over energy in ellipse here. You have energy over energy ellipse in axis ellipse. The demonstration for we can have this expression if the application with the application of asymptotic approach. You have this asymptotic approach for theta equal 0 and or theta equal P under 2. The postulate for the postulate to define this expression is used the equality, this equality, and the root of this equation, you have this expression sigma étoile with the coefficient ARB, BRB, CRB, and we have a test. The test is used in PhD thèse of Bordeaux, and so here you have the analysis of this equation, this polynomial where the minimal threshold stress of function 3 are 116.7, 117.8, 118, 165. The stress, the threshold stress sigma max are upper than the endurance limit. So I use these values and we have Kitagawa curve here with the line and the four solution. This for validate this curve, I use the Bazant law. The Bazant law here. I use this law, and you have the curve of Bazant law, the two curve of Bazant law delineate the value of threshold stress. Bazant law representation include well the shear stress diagram. Hence, consideration of shear stress fatigue analysis may help the damage tolerant design. Fatigue criteria and validation of result. To validate the design of safety component multi-axial fatigue analytical under service loads and numerical method have to be carried out. Fatigue design predicts crack initiation with the mechanical characteristic and the fatigue criterion. The criterion must be the validity presumed 3 reviews for A0. If A non equal 1, the criterion is fired. If A non superior 1, the criterion is conservative. If a non, here you have the multi-axial. Here you have the multi-axial criterion in this expression. The relation is identified, and the criterion validity imposes for damage indicator sigma XTE superior of racine 2 under 2. Here you have some criteria from the literature are used on validation, and here you have six criterion and our criterion. Statistical analysis for forecast performance for fatigue criteria. Here you have Dong Van Tu, Robert, Fruste Lasser, Kakuna, et our criterion. So we can also know the conservative character or not. If I is strict, criterion is strict, superior noun criterion is conservative. If I is inferior, criterion is non-conservative. In conclusion, the study using an over energy method predict the threshold stress leading the small crack. The small crack usually nucleate on plane of shear stress can significantly reduce the fatigue life of engineering. Curve shear stress and crack are in good agreement with Kitagawa plot and Bazant law. We have been able to define the field application for 7 criteria by comparing them. Also, the Dangvan and Robert criteria have a major drawback. We also note about the statistical indicator that our criterion have reasonable value. Further, investigation will aim to validate our criterion by numerical or experimental tests in microscopic observation.